Hi guys, so we are going to do section 3.2 now, and our learning objectives are going to be that we need to know and apply the mean value theorem. Okay, now corollary to the mean value theorem we're going to go over is going to be Rolle's theorem, but that is just the mean value theorem, but more of a specific example. But you need to know the mean value theorem word for word. I mean, this is going to be on your AP test, on my test. Know it word for word. They're in the library. Alright, so let's just kind of review back to the extreme value theorem. That's what we did in the previous section. So if f is continuous, that is going to be our condition that we need, and it has to be on a closed interval. So continuous on a closed interval, then it has both an absolute maximum and an absolute minimum over the interval from A to B. Okay? Now, when I see something like this, that's going to be more of Rolle's theorem. When I have these two values that are the same output, then I know that I'm going to always have a max and min, but we're going to be talking about that here in a second. Okay, so word for word, know this, okay? Know it word for word. So if f is continuous, again we have a condition on the closed interval, but now it's going to have one more little stipulation here. It's going to be differentiable, so the derivative exists. There's no sharp points or cusps or anything like that, okay? So, but it's differentiable on the open interval from A to B. Then there's going to be a C in that interval such that this occurs. So f prime of C is going to equal f of B minus f of A over B minus A. So let's talk about that a little bit. Let's see some different graphs. Well, it has to be continuous and differentiable. Okay? And it has to be on a closed interval, so maybe like this A to, I don't know, what do you want to go? This B. Okay? So this right here, this part, that's just our average value. That's going to be our average velocity. Sorry, not average value. Average velocity. So this is just our regular slope of the secant line. So if I drew a line connecting these guys, the slope of this line is going to be f of B minus f of A over B minus A. So that's the change in our y's over the change in our x's. And that's the slope of the secant line. So what this interval, or what this mean value theorem is saying over the interval, I'm going to see if I can get something a little bit skinnier than that to kind of show you. Here, let me do this paperclip a little bit. Let me pull it out. So basically it's saying that as you move along the curve, there's going to be some C. So C has to be between this A and B. Okay? Where, and this is the fun part. Okay, so if I kind of go through and I'm looking, f prime of C is that instantaneous slope, so it's that instantaneous velocity going on. So if I look at it, is this slope the same? Nope, let's keep going until we get a slope that's going to be the same. Oh, stop. Okay, so it looks like I have one about right here. Whereas if I drew that instantaneous slope, these two guys are equal. Now, that can happen more than once. It just says that there is at least one c, okay? At least one. So let's keep going here. This should say at least one. So, nope, 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 nope. Oh, there's another one that is exactly. So right here as well. So let's just maybe call that guy c sub 1. And then this guy is some c sub 2. So that slope right here is also equal. So there can be more than one, or there could just be one. But the mean value theorem says that there's at least some instantaneous slope that is the same as the secant slope. So let's see if you can write this down here. So go ahead and pause me a little bit. Okay? And see if you can write what you're thinking, and then let's check. So pause. So an instantaneous velocity is going to equal the slope of the secant. This is the slope of the tangent. Okay? So some average velocity. Now again, what are your two conditions? It's important to remember. Don't look up at your notes. Okay, so it has to be continuous on the closed interval, and it has to be differentiable on the open interval. And if those two things happen, then there is a c belonging to the open interval where f prime of c equals f of b minus f of a over b minus a. Okay? Now, again, I told you Rolle's theorem is just going to be a corollary right here. So basically, let's see the difference here. It says that it's continuous on the closed, differentiable on the open, so that's all good. Then it gives us one more thing. It says that f of a and f of b are now the same. So if I look at my graph that was pretty similar, let me see how I do that again. Okay, I think I do it something like this. So let's pick where I get two values that are the same. So like here and here. Okay, so this f of b now equals f of a. With all the other conditions, you know, it's continuous on the closed, it's differentiable on the open. Now they're saying, hey, there is at least some value c, so we had our two conditions, that it is continuous on the closed, differentiable on the open, but the third thing it's saying is that f of b now equals f of a. Okay, that those outputs are now the same. Well, think about this. When I draw the secant slope, what is that slope? No matter what, when two values are going to be the same output, it's going to have a slope of 0. Okay? So if I have f prime equaling 0, oh, those are my critical numbers. So that's where I'm going to find the peaks or the valleys, okay, all those humps. So here when I see that, it's saying that, hey, we want to get the same slope like before of the tangent, and that would occur right here. And that is 0. So basically, Rolle's theorem says that if I have the continuous and the differentiable on the intervals, and I have those two outputs the same, I am guaranteed a max or a min. Okay? So I know that if those things occur, that f prime of c equals f of b minus f of a over b minus a, which equals 0 for some c belonging to the open interval ab. And that's telling me that there is a max or min. Okay, so just to keep it straight, here's just kind of like a little flow chart to kind of help you remember everything. So the conditions for the extreme value theorem just was that f had to be continuous. For the mean value theorem, we had to have continuous on a closed interval, differentiable on an open, and for rules, the corollary, it's still continuous on the closed, differentiable on the open, but now those two values equal each other. And what's guaranteed when I have this is that you have an absolute max and an absolute min here, that f prime of c equals f of b minus f of a over b minus a, so the slope of the tangent equals the slope of the secant. That's the average velocity equals the instantaneous velocity. And here it's guaranteed that f prime of c equals 0 because f of b minus f of a over b minus a equals that, which equals 0, and that I'm going to have a max or a min. Alright, so there's like the big ideas. Now we're going to get to some examples. We'll do that in the next part.